After January 1, 2008, arc fault circuit interrupters, or AFCIs, were required to be installed on all 15 and 20 amp branch circuits supplying bedroom outlets in new construction. This was a significant change in the National Electrical Code, or NEC, aimed at improving electrical safety in homes. Before this requirement, AFCIs were not widely used in residential wiring. The primary purpose of an AFCI is to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults occur when electricity jumps between conductors or to a grounded surface, creating heat that can ignite nearby materials. These faults can be caused by damaged wiring, loose connections, or faulty appliances. Traditional circuit breakers are designed to protect against overloads and short circuits, but they are not always effective at detecting arc faults. AFCIs, on the other hand, are specifically designed to detect these types of faults and quickly shut off the circuit, preventing a fire from starting. The initial requirement in 2008 focused on bedroom outlets because bedrooms are often occupied while people are sleeping, making them particularly vulnerable to the dangers of electrical fires. The NEC recognized the importance of protecting these areas with AFCIs to provide an extra layer of safety. In 2011, the NEC expanded the AFCI requirements to include all habitable rooms. This meant that AFCIs were now required on all 15 and 20 amp branch circuits supplying outlets in living rooms, family rooms, dens, libraries, hallways, and other similar areas. This expansion reflected a growing understanding of the widespread risk of arc faults throughout the home. Habitable rooms are defined as rooms that are used for living, sleeping, eating, or cooking. By extending the AFCI requirements to these areas, the NEC aimed to provide comprehensive protection against electrical fires in all parts of the home where people spend significant amounts of time. This change significantly increased the number of AFCIs required in new construction and helped to reduce the risk of electrical fires in a wider range of residential settings. In 2014, the NEC underwent another revision that further expanded the AFCI requirements. This revision required AFCIs on all 15 and 20 amp branch circuits supplying outlets in all dwelling units, including additions and alterations. This means that the AFCI requirements now apply to both new construction and existing buildings. The 2014 update was a major step forward in electrical safety as it ensured that all homes, regardless of their age or construction type, would be protected by AFCIs. This requirement applies to all dwelling units, which includes single-family homes, apartments, condominiums, and other types of residential buildings. The NEC defines a dwelling unit as a single unit providing complete and independent living facilities for one or more persons, including permanent provisions for living, sleeping, cooking, and sanitation. The requirement for additions and alterations means that any time a new circuit is added or an existing circuit is modified in a dwelling unit, it must be protected by an AFCI. This ensures that even older homes are gradually brought up to the current safety standards as they are renovated or updated. The NEC provides specific guidelines for the installation of AFCIs. These guidelines cover topics such as the location of AFCIs, the types of circuits that require AFCI protection, and the testing procedures for AFCIs. It is important to follow these guidelines carefully to ensure that the AFCIs are installed correctly and function properly. AFCIs are typically installed in the electrical panel, where they replace standard circuit breakers. They can also be installed at the outlet itself, although this is less common. When installing an AFCI, it is important to connect it to the correct branch circuit and to ensure that the wiring is properly terminated. AFCIs must be tested regularly to ensure that they are working correctly. The NEC requires that AFCIs be tested at least once a month using the test button on the device. This test simulates an arc fault and verifies that the AFCI will trip and shut off the circuit. If an AFCI fails to trip during the test, it should be replaced immediately. There are two main types of AFCIs: branch/feeder AFCIs and outlet branch circuit AFCIs. Branch/feeder AFCIs are installed in the electrical panel and protect the entire branch circuit. Outlet branch circuit AFCIs are installed at the first outlet in the branch circuit and protect the wiring downstream from that outlet. The NEC allows for the use of either type of AFCI depending on the specific application. It is important to choose the right type of AFCI for the circuit being protected to ensure that it provides adequate protection against arc faults. AFCIs are an important safety device that can help to prevent electrical fires. By detecting arc faults and quickly shutting off the circuit, AFCIs can significantly reduce the risk of fire and protect lives and property. It is essential to understand the AFCI requirements in the NEC and to ensure that AFCIs are installed and maintained correctly. Electrical safety is a critical aspect of homeownership and should never be taken lightly. AFCIs are just one component of a comprehensive electrical safety plan, but they play a vital role in protecting homes and families from the dangers of electrical fires. Regularly inspect electrical wiring, outlets, and appliances for any signs of damage or wear and tear. Replace any damaged or worn items immediately. Avoid overloading electrical circuits by plugging too many devices into a single outlet or circuit. Use power strips with surge protection to protect electronic devices from power surges. Have a qualified electrician inspect the electrical system at least once every 3 years to identify any potential problems. Install smoke detectors on every level of the home and test them regularly. Develop and practice a fire escape plan so that everyone in the home knows what to do in the event of a fire. These measures can help to prevent electrical fires and protect lives and property. The evolution of AFCI requirements in the NEC reflects a growing awareness of the dangers of arc faults and a commitment to improving electrical safety in homes. By understanding these requirements and taking steps to ensure that AFCIs are properly installed and maintained, homeowners can significantly reduce the risk of electrical fires and create a safer living environment for themselves and their families. Furthermore, advancements in AFCI technology continue to improve their effectiveness and reliability. Newer models are designed to be more sensitive to arc faults and less prone to nuisance tripping. Nuisance tripping occurs when an AFCI trips due to a non-hazardous condition such as a momentary surge in electricity. This can be frustrating for homeowners and may lead them to disable or bypass the AFCI, which defeats its purpose. To address this issue, manufacturers have developed AFCIs with advanced algorithms that can distinguish between hazardous arc faults and non-hazardous conditions. These AFCIs are less likely to trip unnecessarily, while still providing reliable protection against arc faults. Another important development in AFCI technology is the introduction of combination AFCIs. These devices combine the functions of an AFCI and a ground fault circuit interrupter, or GFCI, into a single unit. GFCIs are designed to protect against ground faults, which occur when electricity leaks from a circuit to a grounded surface. Ground faults can be dangerous because they can cause electric shock. Combination AFCIs provide protection against both arc faults and ground faults, making them a comprehensive safety device for electrical circuits. The NEC recognizes the benefits of combination AFCIs and allows for their use in many applications. In some cases, the NEC may require the use of combination AFCIs to provide the highest level of protection. The installation of AFCIs is typically done by a qualified electrician. Electricians have the training and experience necessary to install AFCIs correctly and to ensure that they are functioning properly. When hiring an electrician to install AFCIs, it is important to choose a licensed and insured professional. This will ensure that the work is done to code and that you are protected in case of any accidents or damages. The cost of installing AFCIs can vary depending on the number of circuits being protected and the type of AFCI being used. However, the cost of AFCI installation is typically a small price to pay for the added safety and peace of mind that they provide. Many homeowners choose to install AFCIs as part of a larger electrical upgrade or renovation project. This can be a cost-effective way to improve the safety of the home and to bring the electrical system up to current code. In addition to installing AFCIs, it is also important to maintain the electrical system properly. This includes regularly inspecting electrical wiring, outlets, and appliances for any signs of damage or wear and tear. Replace any damaged or worn items immediately. Avoid overloading electrical circuits by plugging too many devices into a single outlet or circuit. Use power strips with surge protection to protect electronic devices from power surges. Have a qualified electrician inspect the electrical system at least once every 3 years to identify any potential problems. The National Electrical Code is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years to reflect the latest advancements in technology and to address emerging safety concerns. The NEC is developed by the National Fire Protection Association, or NFPA, a non-profit organization that is dedicated to reducing the risk of fire and other hazards. The NEC is widely adopted by state and local governments throughout the United States. It serves as the basis for electrical codes and regulations that are enforced by building inspectors and other authorities. Compliance with the NEC is essential for ensuring the safety of electrical systems. The NEC covers a wide range of topics related to electrical wiring and equipment. It includes requirements for the installation of wiring, the selection of electrical components, and the maintenance of electrical systems. The NEC also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. The NEC is a complex document, and it can be difficult for non-electricians to understand. However, it is important for homeowners and business owners to have a basic understanding of the NEC so that they can ensure that their electrical systems are safe and compliant. There are many resources available to help people learn about the NEC. The NFPA offers training courses, publications, and other resources on the NEC. Local electrical contractors and inspectors can also provide information and guidance on the NEC requirements in a specific area. Staying informed about the NEC is an ongoing process. As technology advances and new safety concerns emerge, the NEC is constantly being updated and revised. It is important to stay up to date on the latest changes to the NEC so that you can ensure that your electrical system is safe and compliant. Furthermore, grounding and bonding are essential components of electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protective device such as a circuit breaker or fuse to trip and to energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Proper grounding and bonding help to prevent electric shock and reduce the risk of fire. The NEC has specific requirements for grounding and bonding. These requirements cover topics such as the size and type of grounding conductors, the methods for connecting grounding conductors, and the location of grounding electrodes. It is important to follow these requirements carefully to ensure that the electrical system is properly grounded and bonded. Grounding electrodes are typically metal rods or plates that are buried in the ground. They provide a connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current. The NEC specifies the minimum size and type of grounding electrodes that must be used. Bonding conductors are typically copper wires that connect all metal parts of the electrical system together. This includes metal conduits, metal enclosures, metal equipment, and metal appliances. The bonding conductors create a low impedance path for fault current, which helps to ensure that the overcurrent protective device will trip quickly in the event of a fault. Ground fault circuit interrupters, or GFCIs, are another important safety device for electrical systems. GFCIs are designed to protect against ground faults, which occur when electricity leaks from a circuit to a grounded surface. Ground faults can be dangerous because they can cause electric shock. GFCIs work by monitoring the current flowing through the circuit. If the current flowing out of the circuit is different from the current flowing back into the circuit, the GFCI will trip and de-energize the circuit. This happens very quickly, typically within a fraction of a second, which helps to prevent electric shock. The NEC requires GFCIs in certain locations where there is a high risk of ground faults. These locations include bathrooms, kitchens, garages, and outdoor areas. GFCIs are also required in other areas where there is a potential for water exposure, such as laundry rooms and swimming pool areas. When installing GFCIs, it is important to follow the manufacturer's instructions carefully. GFCIs must be tested regularly to ensure that they are working correctly. The test button on the GFCI should be pressed at least once a month to verify that the device will trip and de-energize the circuit. If a GFCI fails to trip during the test, it should be replaced immediately. Surge protection is another important aspect of electrical safety. Power surges are sudden increases in voltage that can damage electronic devices. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors are devices that are designed to protect electronic devices from power surges. They work by diverting excess voltage away from the protected devices. Surge protectors are available in a variety of types, including whole-house surge protectors, plug-in surge protectors, and power strips with surge protection. Whole-house surge protectors are installed at the electrical panel and protect the entire electrical system from surges. Plug-in surge protectors are plugged into outlets and protect the devices that are plugged into them. Power strips with surge protection offer surge protection for multiple devices. When choosing a surge protector, it is important to consider the surge protection rating. The surge protection rating indicates the amount of energy that the surge protector can absorb before it fails. A higher surge protection rating indicates that the surge protector can provide more protection. It is also important to choose a surge protector that is UL listed. UL listing indicates that the surge protector has been tested and certified to meet safety standards. In addition to surge protectors, there are other steps that can be taken to protect electronic devices from power surges. These include unplugging electronic devices during thunderstorms and avoiding the use of extension cords. By taking these precautions, you can help to protect your electronic devices from damage caused by power surges. The information provided is for general guidance only and should not be considered a substitute for professional advice from a qualified electrician. Always consult with a qualified electrician before making any changes to your electrical system.